Hello there, I'm Lukács Berki, the tech lead of the Bazel build tool. Today I would like to talk to you about one of the more significant projects, which is to build Android platform with Bazel. That is to say, not individual Android applications. We can already do that, but the operating system itself. First, I would like to talk to you a bit about the history and why we are doing this. Then I would like to talk to you about the difficulties there are. And then I would like to talk to you about what exactly is happening and what accomplishments there are. History. Long and storied. I would like to not dwell too much on the individual items on this slide. What is important is that both the internal monorepo and both Android platform have a story that's almost 2 decades old. Both of them started out from Make, and since then they have diverged. Our internal monorepo is using the internal version of Bazel called Blaze. Android is currently using a version of a bespoke build tool called Soong and still bits of Make. So why build Android platform with Bazel? There are multiple reasons, both organizational and technical. The organizational reasons are simpler, which is to have one single solution to the same problem and not two. This decade and a half of parallel development resulted in different solutions to the same problems, and developers do find it hard to move from one world to the other. I speak from experience. I spent a whole lot of time in our internal monorepo, and then when I started working on Android, it took me quite a bit of time to learn all the separate tools. And it's better for other developers not to have the same experience or the opposite of it. The technical benefits are also many. First off, we do provide a way to execute build actions remotely, which is important because Android is a big operating system, and one of the biggest complaints there are is that builds are slow. Distributing the build over multiple computers helps with that. Bazel also provides a sandbox for individual actions, which is important for incrementality. That is to say, this is how Bazel makes sure that when an input file is changed, only those actions are rerun that are actually affected by the change. Nothing more and nothing less. This creates trust in the build tool because, as anyone has ever said, make clean knows that when this happens, when incorrect incremental builds happen, that can give rise to hours and hours of wasted time of debugging. Bazel also provides a number of tools to look at the structure of the build. For example, to look at the structure of the action graph, that is to say, the graph that is composed by the actions and their input and their output files, and the individual targets, for example, C++ or Java binaries or libraries. Last but not least, Bazel has a vibrant community, both inside and outside Google, which is useful for one to get started with building Android. Of course, life is not simple. The next few slides will be about the difficulties that are on the way. The root cause of almost all the difficulties there are is that, as said before, Android platform and our internal monorepo have different long histories. Now, the good part is that Soong, the build system for the majority of Android, was modeled after Bazel and was developed with full knowledge of Bazel structure. And the other good part is that Android's build does not need to be fully converted to Bazel to see benefits. The bad part is that even though Soong borrows some concepts from Bazel, it's just not quite the same, which makes the integration between the two tools hard. And there will be a long migration phase because we cannot just wave a magic wand to turn Soong into Bazel. What's even worse is that the migration to Soong has not been finished yet, and therefore, for a while, there are going to be 3 build systems in Android platform. That is to say, Soong, Make, and Bazel, which makes interoperability not so easy. Of course, there is a reason why Soong is different from Bazel, and that is mostly because the world of Android is also different than the world of the internal monorepo Bazel grew up in. The internal monorepo is a, monorepo, which means, among other things, that it's much more uniform. We have a uniform testing environment. We have a uniform environment to deploy to. Okay, not completely uniform, but clearly it's much simpler than the land of Android, where there are many, many different devices which all need to work. In addition to that, when one talks about Android platform, it's not really one code base. It's more like many different code bases. The biggest difference is that there is AOSP, which is a large part of Android, but not all of it. And there is the full Android source tree. But in addition to that, different partners Google works with, that is to say, companies who make chipsets or companies who make the actual devices, have their own code they add or remove to Android. And there is also the effort to build parts of Android separately, such that they can be deployed separately to the actual devices. That is to say, to do partial system updates, which is called Project Mainline. In order to be certain that a part of the operating system can be deployed separately, it also has to build separately, which is yet another way to slice and dice the source tree. Android also comes from a hardware background, unlike our monorepo, which comes from a software background, which is salient in a number of ways. For example, Android puts much more stress on integration testing. That is to say, uploading software to an actual piece of hardware and see if it works, and less emphasis on unit testing. That is to say, testing a small piece of code separately. This is the exact opposite what we have in our internal monorepo, where the rule is unit testing with a few integration tests sprinkled between. And of course, we have the biggest problem, which is the problem of every developer that has ever maintained a code base with a long life, which is legacy code. Now, in the background, you see COBOL. That we don't have, but those almost 2 decades of history have resulted in code that is sometimes not so easy to live with. So what's happening? There are 3 projects that are happening at the moment. The first is executing actions through Bazel. The second is doing the product configuration through Starlark, Bazel's configuration language. And the third is to run mixed builds with Soong, Bazel, and Kati. Kati is a term of art in Android land. It's a reimplementation of Make that was done a few years ago for performance. I would like to show the state of Android's builds before Bazel came around. I understand this graph is somewhat complicated, but the essence is that the build consists of 3 steps. First, what you see on the left is the product configuration part, where it is decided what exactly needs to be built. Its input is a bunch of make files that is processed by Kati, that is to say, the reimplementation of make Android has, which turns it into a set of configuration variables. These variables are ingested by Soong, Android's bespoke build tool, and another instance of Kati, which also take blueprint files and make files, that is to say, the configuration files of Soong and Kati respectively, and turn them into Ninja files, which are the description of the action graph, that is to say, the command lines that need to be run to do the build, and their input and output files. Then after this, a tool called Ninja takes the Ninja files and actually executes the builds. Where we want to be? Well, where we want to be is much simpler. We want to have build files, that is to say, the configuration files of Bazel, that describe both how to build things and what to build, have it ingested by Bazel, and have Bazel execute the resulting actions and output a system image. So what is the state of the affairs now? It's slightly more complicated because it's an intermediate phase. On this diagram, the green boxes are the pieces of code that are implemented for the migration. Firstly, for the product configuration, there are 2 new tools. One is to convert the make files to Starlark files with the extension Bazel, that is to say, Bazel, and a tool to interpret those Bazel files to emit the configuration variables that used to be emitted by Kati. Then, in addition to Soong and Kati, we have Bazel and build files, its config files, and a tool to convert the configuration files of Soong to build files. We call this tool BP to build, that is to say, blueprint to build. Currently, Bazel also emits Ninja files in order to facilitate two different ways of executing actions. The legacy mode with Ninja and the new mode with Bazel, which gives one access to all the goodies Bazel provides. These three work streams are in various states of completion. We are the further along with action execution. Bazel can run a full Android build as the action executor. What remains is to make sure that the action graph is well specified. That is to say, each action has its inputs and outputs declared properly, which is important for incremental builds, and to integrate Bazel's remote execution client into the build. Currently, there's a way to run builds remotely using a tool called RE client, which is a command line tool that can be called either by Ninja or by Bazel. The second workstream, product configuration, is also seeing good progress. The make to Starla conversion tool has been implemented, and there are no known bugs in it. And there is good progress on integrating it into the actual build. What remains is actually converting the make files to .bzl files and checking them into the source tree. The largest challenges there are in the third workstream, that is to say, integrating Bazel into a build with Soong and Kati, because that's when there needs to be a conceptual mapping between the concepts on these three build systems. And it turns out that all three have a complicated conceptual model that needs to be reconciled somehow. Current work is being done on finding a mapping between the concepts of Soong and Bazel. Kati, not so much, because the world of Kati is much simpler. And there is progress on implementing an automatic conversion tool. Checking in build files instead of blueprint files haven't been started yet. We'll start once there's enough confidence about the fidelity of said conversion tool. I would like to talk about action execution, that is to say, using Bazel as a better ninja. This was work that was much easier than expected, mostly because the interface to action execution is pretty narrow. An action, after all, is a very simple thing. It has input files, output files, and a command line that one needs to execute. The work required some design compromises in Bazel, but nothing too serious. And it actually worked while requiring only very small changes to handle platform, mostly to specify a missing input or output here and there. This is not default yet, but I'm very confident that Bazel can actually work as an action executor, and it provides a bunch of benefits already. One can use Bazel's remote execution engine, one can use Bazel's action sandbox, one can use Bazel to query the action graph of the build, and Bazel also provides change pruning, that is to say, the ability not to re-execute an action when its upstream actions have been executed but did not change their output files. For example, when you add a comment to a C++ source file, then the compile is re-executed, but the object file it emits is not changed. Therefore, you don't need to actually rerun the linker. The product configuration is a more interesting part because it's unique to Android. It's a part of Android that is not touched very frequently, and therefore there is not a lot of knowledge spread about it at Google and at partners. It's a way to describe in a modular fashion what exactly needs to be part of a system image, and it's built on the 1976 vintage make build tool. The idea is to say things like, I want to build this device, and this device should have an AOSP image, but with this Android app in addition, and with a few parts removed. Since it's built on top of make, there isn't a lot of error checking in there, and it's not very well tested. But on the flip side, the make files describing the product configuration are well structured and kind of easy to understand what they want to do, which is to our advantage because it makes it easy to build a parser. Actually, I'm saying parser, but sometimes one doesn't actually need to parse make. one can only use a text-based method to understand them and to turn them into star-like files. Here's an example of how a makefile looks like. That is to say, this product should be like cuttlefish with a package called craftsvm in addition, and so on. And here is how the same concept would look like when described in Starlark. The last thing I would like to talk about is mixed mode builds, that is to say, making Soong and Bazel, and to a lesser degree Kati, interoperate with each other. The end result of this system will be a tool to convert the configuration files of Soong, that is to say blueprint files, into those of Bazel, that is to say BZL files. We wanted this tool to be mostly automatic because that's the only way we can migrate the code at scale. It will probably not happen. It will probably need some manual help because both Soong and Bazel have rich conceptual models, and there is no point in implementing an automatic mechanism for migrating things that is used just once or twice in the code base. But we do want the overwhelming majority of the migration to be automatic. The reason why this is difficult is that because Soong and Bazel are extensible in different ways. Soong is extensible in Go, which means that extensions can use the full power of Go. And Bazel is extensible in Starlark, which is a very limited programming language with a very limited API. We want to migrate code that can do more to a system that can do less. Now, Starlark has these limitations for a very good reason. This is what provides opportunities for Bazel to do sophisticated ways of caching, but it's a difficulty. The other difficulty we are facing is that we don't want to make the lives of people who work with Android harder, not even temporarily, which means that we have to be careful to slot Bazel into the build process in such a way that it doesn't make builds slower or less comprehensible. Admittedly, this is difficult. So what is it that has already been accomplished? On Bionic, there's good progress. We can build Bionic in such a way that is bit by bit the same as the build done without Bazel. What remains, however, is building Bionic in all the various ways in which it's built within the build. For example, it's built with various sanitizers, ASAN, UBSAN, and so on and so forth. It's built so as to provide an interface for various Android API levels, such that it can be linked against by applications requiring those various API levels. All this remains. Executing the actions comprising the build with Bazel is mostly risk-free. The Pixel 3 system image can be built with Bazel without problems, which means that I'm pretty confident that everything else can be too, but it's Pixel 3 we tested it with. And now one can start adding edges to the action graph to make it fully declared and incremental. I also consider product configuration a source problem. It's not integrated yet into the build, but the translator is already operational, and there are no known bugs on a full build, which means that there are probably no serious bugs that remain. So it appears that most of the risk in the past. There is still some risk left, and I think that a large part of that risk will be gone by the time we can build Bionic in all the ways that it needs to be built during a full build. But all in all, I'm happy with the progress so far. On to the future. Thank you for listening to this talk, and I hope you will follow further developments on this project.